Thanks for joining us on our first Power Hour of the year. I'm Chris Wooldridge, Sales Engineer with Dorsey and Company, and this is being presented by the engineering support staff here at Dorsey. So if you can look at some of the other cameras that are open on your screen, we have John Neeson, our newest sales engineer here in Seattle, Scott Boucher, our Vice President of Engineering, and Blake Bonham, who is our sales engineer in our Spokane office. So if you have any questions at all, feel free to get with one of us or your particular Dorsey rep, and we get things handled for you. Well, today we're going to kick off the life safety damper presentation. We have Alex Talwar with Greenheck application engineer joining us. He's actually based out of the Greenheck headquarters in Schofield, Wisconsin. And with that, Alex, I'm going to let you take over. Oh, one quick thing. If you have any questions, please put it in the chat. We'll be monitoring those, and I'll interrupt Alex if it makes sense at the time. If it makes sense to hold it to the end, I'll do that. But I'll be monitoring the chat for any and all questions. So thank you. Take it away, Alex.
Perfect. Yeah, good call. I tend to ramble sometimes, so it'll be good to keep me in check there. All right, yeah, real quick on myself, I have been working with Greenheck dampers for going on 10 years now. About half that time was in our dedicated damper louver test lab, so good kind of background, getting my hands dirty with that side of things, the testing, especially the life safety products. So that's really kind of my background with the damper group there. Last 5 years, been doing this kind of educational type of role. So here are the learning objectives for the presentation. Hopefully we'll have time to hit on most of these, just really talk about the different product types, some of the certification and testing that goes along with those products, talk about some options and accessories and some installation requirements and some alternate installation possibilities as well, and then finish up with kind of testing and maintenance requirements. So when we talk about life safety dampers, really kind of main different categories: fire dampers, smoke dampers, the combination products that also includes corridor dampers, but combination fire smoke damper, FSD products, and then the oddball kind of ceiling radiation dampers. So hopefully we do have a little bit of time to talk about those today as well. First of all, fire dampers, really purpose being required by building codes. Essentially maintaining the fire resistance rating of fire rated construction when they are penetrated by HVAC openings. So they are tested to Underwriters Laboratory Standard UL 555. And for us, our models are DFD, Dynamic Fire Damper Group. The R at the end would be the round model, and then FD for Static Fire Damper, and FDR for the round static fire damper. Essentially, the purpose being of these products is to restrict the passage of flame. So it's as defined in NFPA 80, but ultimately detect an increase in heat and close and restrict the passage of flame from one area to the other. Ultimately compartmentalizing these buildings into separate zones and preventing the spread. Smoke dampers, similar purpose, except instead of preventing the spread of flame, now we're talking about limiting leakage when they close and preventing the spread of smoke throughout a system. So slightly different purpose, obviously, different kind of requirements, different features on the products, right? We'll see seals along the blade edges and the edge of the frame to help seal up when they are closed and prevent that spread of smoke when it's pressurized against a closed damper. So they have their own separate test standard, UL 555S, and for us, pretty simple SMD smoke damper models, or SMDR. NFPA 80, control the movement of smoke, defines it that way. Obviously, as the name suggests, the combination FSD products perform the function of both an individual fire and smoke damper, so they carry both the UL 555 and 555S rating. FSD is the typical kind of fire smoke damper. The CFSD is that corridor fire smoke damper product that gets installed horizontally in kind of the tunnel corridor construction. And then at the bottom there, you see GFSD and OFSD. So those are kind of special out-of-wall models. We'll talk a little bit more about those later once we get into the installation phase. And I do have a couple slides here on ceiling radiation dampers. So a little bit different than a fire damper, although they do also have a fusible link to kind of hold them open. But they, the products currently aren't really tested to close against any dynamic airflow. And really the purpose is not necessarily to restrict the spread of flame, but to restrict the spread of radiant heat transfer into a floor ceiling or roof ceiling assembly. So a little bit different purpose, similar sort of construction, but due to the nature of the test, you can end up making them out of a lot lighter gauge material, and being that you're only limiting heat transfer and not necessarily trying to restrict flame, although that would certainly make it difficult to pass a test as well, of course. But yeah, different purpose, different product. They are protecting the ceiling membrane of a floor ceiling or roof ceiling assembly. So whereas a fire damper, we're talking about a complete through penetration of a rated assembly. In the case of a ceiling damper, we're only really talking about protecting that initial membrane layer of the floor ceiling or roof ceiling assembly. And again, we're talking about limiting passage of heat transfer, not complete kind of flame through or protection in that regard. So just something to keep in mind there. Here's a good side-by-side, on the left, ceiling damper protecting that ceiling membrane, on the right, fire damper protecting that full penetration of, in this case, concrete floor. Horizontal fire dampers are pretty limited in how they can be installed themselves. So good side-by-side difference there between the CRD ceiling radiation damper and the FD or DFD fire damper. And I do also have a slide that spells it out too. So there we go. You can see they're tested at different standards as well, right? So bottom line, a ceiling damper is not a fire damper, right? So that's what all of this is intended to kind of illustrate. Hopefully I will have time to talk about ceiling dampers later if I get a move on here. So when we do talk about these products, a lot of different organizations get involved, right, in some form or another. I already talked about UL, Underwriters Laboratory. They're the kind of certification organization. Obviously, IBC, International Building Code, that's driving a lot of these requirements in the first place, dictating rated construction and what type of product you need if you do have an HVAC penetration. And then NFPA also does get involved with kind of the post installation and periodic inspection. But ultimately, all of these things come together, and anyone involved with these products needs to make sure that we are meeting these three elements once we are getting these products in the field. So, you need to pick the correct product for the correct barrier, right? You need to have some type of a rating, fire rating, smoke rating, whatever it is, understand what the barrier is and what type of product is required. If you need a fire damper, smoke damper, both, right? It has to be a listed product. So that's number two. It's got to be a UL certified product. So that is another requirement of the International Building Code, in fact. And then none of that does you any good unless you are installing per the manufacturer's ULA approved installation instructions. So, you pick the right product for the right barrier. It's a UL product, but someone installs it however they want. We don't know if that installation method is approved necessarily unless we are sure that they are following a manufacturer's installation method or approved alternative. So there are other possibilities as well for installing these products, but it does need to be a UL approved document that has been adhered to. These are really just reference slides here. International Building Code, if you are curious, section 717 is where the kind of damper portion is called out there, in ducts and air transfer openings, and really defines a type of product for each kind of category of construction. So this slide here is really my favorite one for a reference slide. So I always like to include this one. If you want to take a screenshot or something, you're more than welcome to. But of course, if International Building Code, you have access there, section 717.5, you will find all of this information in there, dictating what type of product you need for what type of construction. So NFPA, I'll talk a little bit more about this later. Here's just kind of a list of standards that touch on dampers as far as NFPA goes. You notice this is fire doors, but dampers are also included in these standards as well. Not going to spend too much time on here right now. UL test standards, you can see there we have a separate one for fire, smoke, and ceiling radiation dampers. And then UL also does do something called a follow-up service program, essentially a factory inspection, making sure that we are building the products the same way that they are approved and were qualified when they were tested. So that's certainly a very important aspect. If we want to make any changes to our products, to our components of our products, to our materials, we'll have to, run that through Underwriter's laboratory and make sure that it is an approved change, or maybe we have to retest something. So. All right, in terms of purposes of the products, I kind of touched on this already. International Building Code requires that we put these products in there, but why do they require it? Ultimately, to prevent the spread of flame or smoke throughout a building, compartmentalize larger buildings into smaller zones, ultimately creating a longer amount of time for people to get to safety and for the building to maybe even stay intact and not collapse. So a lot of reasons why these products are required and why they have the title life safety dampers. They are saving lives. So compartmentalization is really the purpose of the International Building Code driven requirements. But we do also see them in more of an active exhaust type of scenario as well, right? These are engineered smoke control systems where if we do sense a fire, we might want more than just sense flame or smoke and close damper, right? You might want to actively exhaust that smoke out of an area, prevent cross-contamination in other areas. So it's a very simple example here of a smoke control system. But this is something that would fall kind of a little bit more outside of the International Building Code requirements and go a little bit deeper into the individual smoke control systems themselves. So I'm not going to go too much deeper than that into smoke control systems. I'm really going to stick to the kind of main requirements and things to be aware of in terms of the products themselves. So for fire dampers, we will start with UL 555 fire damper certification. This one's the good pictorial, the fire dampers for dummies slide, right? Oh, if you don't have a damper, then the flame could get through the ducts. So we put a damper in the duct to prevent the spread of the flame. But it is a good kind of side-by-side pictorial to give you an idea. And again, to re-illustrate the point that these products are preventing the spread of flame from one area to the other and maintaining the fire resistance rating of the construction that it is installed into. So in terms of how they work, typically for a fire damper, we'll have a damper, either that's a curtain style damper like we see on the left there, or a multi-blade style fire damper that we see on the right there, held in the open position with some type of heat responsive device. Now, this is usually some type of fusible link that we see in the middle there. So that'll be kind of hooked on to a couple of hooks basically on the curtain damper, holding that accordion-like blade stack in the open position. And then for the multi-blade, it's on a spring wound shaft. So once that link separates, that'll allow that spring to engage and the blades will slam shut on that multi-blade style product. But these fusible links do have melting temperatures. I probably got a slide on that here coming up in a bit. But essentially heat response device. So once the heat increases, minimum 165 degrees, that link will separate and allow the damper to slam shut in the opening and provide the intended purpose, right? Prevent the spread of flame from one area to the other through the duct or opening in the wall. So I pretty much covered this already, curtain style products. So one thing we will talk about coming up here is the ratings of the products being static or dynamic, essentially meaning if they're tested to close against airflow or not. Static rated products are okay to be used in systems that are going to either automatically shut down in the event of a fire or do not have any significant airflow, like an air transfer opening, something. Otherwise, if you do need them to close against airflow and withstand pressure, they'll come with dynamic ratings, a little bit more heavily engineered, heavier gauge springs to help them close and stay closed. But curtain style products, certainly the most cost effective type of fire damper. But the multi-blade products do have a couple of advantages as well, right? You can use them as a balancing damper. They've got this manual quadrant on them, so you can set the blade position, lock it into place, still have the spring wound shaft with the fusible link closure on it. In terms of manufacturing, we are using galvanized steel for the majority of these products. We do have options for stainless models as well. No aluminum fire dampers due to the melting point of that particular material. So kind of touched on this already in terms of static or dynamic. I'll talk about the airflow ratings here in a minute, but the hourly fire resistance rating, that's certainly something that's important. They come in two types, 1.5 hours or 3 hours. Essentially, that's just how long they are subjected to the UL fire test for. But those are your two damper ratings. I'll talk a little bit about how that applies to the construction and kind of IBC requirements in a minute here. Mounting position is also important. So, if this product is going vertical mount in a wall or horizontal mount in a floor or ceiling, again, see if it is going to the ceiling, make sure you actually need a fire damper, not a ceiling radiation damper. But there are differences in how these products are manufactured based on if they are vertical or horizontal. So that is important to know up front. They're not universal mounting. And then in wall or out of wall in terms of installation. So we do have specialized products that allow you to get the damper itself, the damper frame, actually offset from the wall up to 7 or 8.5 inches, I believe. But those are specialized products. They come wrapped with a thermal blanket. They're tested separately. So that is something that you'll need to know. Typical installations are standard kind of in wall. The damper will have no problem being within the wall. It's only those kind of specialized installation, maybe shaft wall. You want that internal grill access where you might need that out of wall access or out of wall damper, sorry. But again, it is important to know up front, we can't just convert these dampers in the field. They're built a certain way to a UL spec based on when we test and qualify these products. So, all right, here's the important slide with the hourly fire resistance rating. So our 1.5 and 3 hour rated damper, we can use that 1.5 hour rated damper in construction that's rated up to, but not including a 3 hour fire resistance assembly rating. So if we have a wall that's rated 2.5 hours, we can use that 1.5 hour rated fire damper in that wall to maintain that rating. Once you hit that 3 hour wall or floor rating or greater, 4 hour assembly rating, then you need a 3 hour rated damper. So that's word of caution to avoid over-speccing if you don't need to, right? You don't pick a 3 hour damper if you don't need a 3 hour damper, because that could limit your options, could start becoming more expensive and things like that. So 1.5 hour rated damper, good to use in 2 hour, 2.5 hour walls, 2 hour, 59-minute walls, not a 3 hour wall. Once you hit that 3 hour rating, now you need the 3 hour damper, but you can also protect a 4 hour assembly as well. All right, I probably don't have time to do this, but it's always so fun. So I'm going to show the fire test here. This is from our lab in Schofield, Wisconsin here a number of years ago. Actually, my boss is the lab manager, I think, in this video here, but this is our large vertical test furnace, UL 555. It has 2.5 million BTU per hour burners on either side of the furnace, pumping flame into the furnace, following a prescribed time temperature curve. So we start at ambient and ramp up to 1,000 degrees in the first 5 minutes of the test. Start with the damper in the open position, let the heat response device, fusible link, activate, close the damper, and then stand back and watch it burn essentially for 1.5 hours or 3 hours. So here you can see we're in the middle of the test. It's glowing orange. You can physically see the galvanized zinc material kind of fading away from the blades. Pretty cool test to witness. Doesn't smell great, but during the test, there's not a whole lot you can do except for watch it. If you do see any flame make its way through, it's an automatic fail. So we're always looking for that. We've got our UL witness here in the video. You might point him out. He's the one who's not wearing any personal protective equipment in there. So then after the test, this is after the exposure, 1.5 or 3 hours. This was probably an 1.5 one here. And we do have to test in both directions, right? These ratings are for both directions. So if you notice in the video here, multi-section damper, one row is facing one way, the other row is facing the other way. So it's a little bit of a 2-for-1 type test here. But this hose stream, this is all part of the test as well. So after being subjected to that time temperature curve, which gets up to almost 2000 degrees by the end of the test, now we're hitting it with a 30 PSI hose stream for the 1.5 rating. And it's actually a 45 PSI hose stream for the 3-hour rating. So this is really the most difficult part of the test here is hitting it with the impact of that water, temperature shock, all that kind of stuff. And after absorbing all of that force and temperature and fire and water and all that stuff, now our UL witness will start taking measurements, and you are allowed 1/8 of an inch for a through opening for a tolerance. So I mean, think of how big 1/8 of an inch is. We'll have a rod that's 1/8 of an inch in diameter, and our UL guy will be poking around the corners of the product and making sure he can't push that rod all the way through. So that is your tolerance for a through opening for passing these UL fire tests. Pretty tricky test to pass, but that's why, if you're ever wondering why are there all the, installation requirements and why do I have to do this with my retaining angles, it's because we have to pass these fire tests and they're pretty tough. So again, anytime we want to make a larger section size or something like that, or go bigger or introduce a new feature, we may have to undergo a kind of full testing project. So all right, let's talk about the operation here of the product. Fusible link is the activation or heat response device. You can see the kind of standard temperatures listed here, 165 up to 350. International Building Code does call out a closure temperature, or they I forget how they actually say they say approximately 50 degrees above the normal temperature within the duct. Well, I mean, what does that mean? You don't want your temperature spiking up and having this thing trip. So 50 degrees above whatever the max temperature that it's typically going to see is a good kind of a good buffer to give it in terms of your melting temperature. Standard, ambient air, if you're not heating or you're not living in too warm of a climate, 165 is the minimum standard link and usually okay for a majority of applications. But again, if you are dealing with heated air, you might want to bump that up a little bit. Talked about this one already in terms of static versus dynamic, right? So typical static dampers at air transfer opening, it's not going to be seeing significant amount of velocity going through there or have to withstand against a ton of pressure. So, or if we're tied into a system that automatically shuts down in the event of a fire, that damper won't need to close against any velocity or pressure. So a static rated fire damper is needed in those cases. Otherwise, if there will be fan pressure or airflow that may be on during a fire incident, we'll need a dynamic rated product, and we'll need to have these dynamic ratings. So velocity ratings established every 1,000 feet per minute, starting at a minimum of 2,000 feet per minute. And that's established when the damper is in the open position. And then the pressure rating when the damper is closed to be able to withstand those pressures listed there, minimum of 4-inch water gauge, and then in increments of 2 inches above that. So again, to avoid overspecking, word of caution, broadest product offering is always available at the lowest ratings. You can make your dampers bigger, it's easier to pass the tests. they cost less usually. You can use less material, all that kind of stuff. So of course, there will come a time where you do need those elevated ratings, 3,000 feet per minute velocities, things like that. But just be aware that once you start bumping up in the velocity and pressure ratings, it will limit you in terms of the kind of maximum allowable sizes of the products and things like that. So just a word of caution on that. Mounting orientation, I did cover that earlier. Just a little more in depth here on this slide. Obviously with curtain style products, right? If you have a static rated damper in a wall, we're not going to put a spring in there. It'll just close via gravity. Now, if you're putting that on its side and putting it horizontally in a floor, you don't have gravity working in your favor. So there are differences in the design of the product. So again, something we'll need to know up front. The product actually does come with a label on it, signifying if it's for vertical mount only or horizontal mount only. But of course, again, airflow, if it is a dynamic rated product, will always be both directions. In terms of transitions on these curtain style products, the type B is always a popular one. That'll get your curtain stack out of the airstream, increase the free area, decrease pressure drop. Just one word of caution, if you are looking at a type B, just be aware that your H dimension, the height dimension, matches up with the duct, but then your O dimension, the opening dimension in the wall, is going to be a little bit different, right? So we do have charts for that. You can look it up, but just be aware that there are differences between that H and O dimension when you're making your drawings and things like that. See the other different shape type of transitions as well, so square to round and that type of thing. Of course, if we do have round ductwork, instead of paying the extra cost for the square to round transition, you might want to consider just a true round style product. A lot of advantages to these products, typically lower cost, usually easier to install, doesn't not need a round hole in the wall. It'll get framed the same way a square damper does. And it comes with the retaining plate, UL approved installation methods. So a lot of advantages, and usually better pressure drop too. So a lot of advantages to the true round style products if you have round ductwork. There we go. I could have just gone to the next slide and saved my voice, but true round. We do have a video, I think, as well on the website if you're interested in learning more about those products. But yeah, a lot of advantages there. So recapping the fire damper criteria, I think I'm actually doing pretty good here. Fire rating, right? 1.5 or 3 hours. Actuation temperature, fusible link, melting temperature, 165 standard. Do you need to go higher than that or not if you have heated air? Something to consider. Your velocity and pressure ratings for the dynamic rated products versus a static rated product that is not tested to close against airflow. Importance of mounting orientation, vertical or horizontal. And then just being aware of size limitations on these products. Again, having to pass the fire test always is a difficult thing. So just be aware that those things exist. So let's jump into smoke dampers. I do apologize if it seems like I'm going fast. I do have a lot of information to share today. So smoke damper products, typically configured in that kind of multi-blade style that we see there. Here are the ratings. So they're going to have the same velocity and pressure ratings that dynamic fire dampers do. This time, though, we are now introducing a leakage class with UL 555S smoke damper ratings. So class 1, 2, or 3. Class 1 is the best performance. Class 3 is the worst performance, and actually not even allowed by the International Building Code. So if you want a IBC qualified damper, it's got to be a UL 555S class 1 or 2 product. So you can see those leakage classes listed there. Class 1 means you're allowed 8 CFM of leakage per square foot of damper area at a 4-inch test pressure. It's actually 4.5 inches. We're always bumping up the test and velocity pressure and for a safety factor. But I'll go a little more into what that kind of means a little bit deeper on the next slide. but essentially from class 1 to class 2, right, you're going from 8 to 20. And then from class 1 to class 3, you're going from 8 to 80 allowable at that same test pressure. So just to kind of give you an idea of the steps of class 1, 2, and 3 there. And although it is a smoke damper and we are not testing it against fire, we are still testing it under elevated temperature because it will need it to operate at an elevated temperature potentially, right? In a fire event. Again, the purpose of the product is not to prevent the spread of flame, but it does need to operate in these types of conditions. So 250 or 350 degrees will be the rating of the smoke damper and the actuator as well, whether it's external or internal. So let's put that leakage class into a little more realistic terminology, realistic in terms of stick figures sitting in a little cartoon room here. But if that is a class 1 rated smoke damper there, protecting those stick figures, they will have 100 minutes of time to get to safety. If it's a class 2 rated product, it's cut almost in half, a little bit more in half, but they should still have plenty of time to get to safety, 40 minutes, and then class 3, maybe 10 minutes to get to safety. So, there's kind of the step again between class 1, 2, and 3. Class 1 and 2, hopefully there are really no class 3 rated products out there. I'm not even sure we make one, to be honest. In terms of construction, again, multi-blade construction. So we have 3 different types of blades available for the rectangular style products, and then we have the round product as well. 3V style blade is kind of the most cost-effective blade, also going to be our lowest rated type of product as well, right? So if we need to start bumping up to higher ratings, we'll probably start looking into those airfoil type of blades. So we have that fabricated steel airfoil blade, as well as the aluminum, extruded aluminum airfoil blade now available to us for these smoke products. So we do have the aluminum style products available, and to help us pass these leakage tests, we will use blade and jam seals. So some type of silicone seal usually along the blade edge to seal up blade to blade. And then it's a kind of springy stainless steel type of jam seal, we call it, along the edge of the damper frame to seal up against the frame and the edge of the blade. And then in terms of smoke dampers, we are able to build them much larger than fire and fire smoke just due to the nature of the testing and things like that. So not quite as many size restrictions there. In terms of how they work, multi-blade damper with a spring return actuator that is connected to some type of a smoke detector or detection system. Once the system detects smoke, it sends a signal to the actuator, actually cuts the power to the actuator, and then there's a spring mechanism in there that automatically closes that damper and seals up to prevent the spread of leakage or spread of smoke throughout the building. In terms of actuation, I don't want to go too deep into this. IBC covers the smoke damper actuation and acceptable methods of detecting smoke. You can use duct smoke detectors. It'll tell you where it has to be within 5 feet of the damper, things like that. Again, I don't want to go too deep in there. It's in section 717.3 if you're interested. But the actuators, these are very important with smoke and fire smoke dampers. The actuator model is tested with the damper model. So, we'll have certain combinations of actuator models that we can use with certain combinations of damper sizes. They have different torques, different performances, all that kind of stuff. Again, we are testing them as kind of a unit. So they're both subjected to that heat test as well, 250 or 350 degrees. So even if it's an external actuator, we'll put an oven box around it, heat the actuator as well, make sure that thing can function under heated conditions. And before we can do any of that, we actually have to do a cycle test on the damper and actuator. So make sure that the actuator has enough torque to operate that damper for 20,000 full open and closed cycles. And in the case of modulating actuators, it's got to do an additional 100,000 reposition cycles. So 10,000 cycles from 0 to 10%, 10,000 from 10 to 20. Takes a long time, right? I think it's like 3 months for something like that until you even got a test sample you can throw up on your air chamber. Typically, actuators these days are electric, 24, 120 volts, something like that. Usually we'll see transformers for anything higher. Two position actuator, just open and close, or we do have modulating capabilities for actuators as well. They're not exactly cheap, but if you do want to be able to hook that fire smoke damper up to some type of modulating control, give it a 2 to 10 or 0 to 10 volt set point signal, or hook it up to an airflow set point and modulate your damper, we do have those capabilities. So I'm not going to talk too much about pneumatics. I don't see those a ton anymore. And then quick recap on the actuator slide here. Larger dampers may need more than one actuator. So if we're starting to get into those large openings, large dampers, one actuator may not be enough. So we certainly may need more than one on those bigger models there. 250, 350, talked about that. And yeah, various torque ratings as well. So the actuator model is very closely tied into the damper product itself. Combination fire smoke damper, so same level of protection as a UL 555 fire damper and a 555S smoke damper. So it's got your hourly fire resistance rating, 1.5 hours or 3 hours. It's got your leakage rating, class 1 or 2, hopefully not 3. It's always going to have a factory mounted actuator. So it's got to come from the factory with an approved actuator model for that damper model and size. And of course, we're always going to see these products with dynamic airflow ratings, right? So 2,000, 3,000, 4,000 feet per minute, 4, 6, 8 inches of pressure, elevated temperature ratings. All of that stuff comes into play here. So again, installation.
Hey, Alex.
Yes, go ahead.
We got a couple of questions. Well, one real quick. Why would you need a modulating damper?
I mean, why would you need one? Really, the only need for modulating dampers if you're trying to really combine the functionality of a modulating volume control damper into your fire smoke damper. So it's kind of the Cadillac of dampers. You got every possible functionality. Yeah, it's a volume control application built into the fire smoke environment, basically.
Right. We don't see that one too often, but like I said, instead of having to have two dampers in that duct, stream and two elements of pressure drop, you can, do the proverbial
Sure.
two birds with one stone situation of control and protection. While I have you interrupted, we did have another question just a few minutes ago in our chat. For two independent combination fire smoke dampers getting installed side by side in an existing concrete opening, what type of architectural assembly needs to be added between those two dampers? It's kind of a tough one for you.
Yeah. I mean, anything that could maintain the rating, I suppose. Yeah, that you are right to point out the fact that if you have two dampers in one opening, that's kind of a no-no, right? You can't put them both in there together, but if you can separate that opening into two separate openings, then that gives you a shot. Question being, what do you use to separate those openings? Off the top of my head, I don't have a quick answer for you. I mean, in terms of something that will maintain the rating, but I can certainly look into it, and I can ask my boss. I know he's run into a lot of these kind of things before out in the field, so I'd be happy to shoot the question over to him and get you an answer.
Excellent. Thank you.
All right, we will keep rocking along here with the fire smoke damper portion. So talked about the product itself, the ratings. We're going to see actuators like we did with the smoke dampers. However, now for a heat response device, the typical heat response device, instead of a fusible link, is going to be that little kind of cup that you see in the top left picture there. called the RRL, Resettable Reusable Link. Essentially, it's a little thermostat built into this cup. And then once the heat increases, gets to that 165 degrees, that thermostat pops in and cuts the power to the actuator, allows the spring return mechanism to close the damper. We do also have fusible link closure mechanisms available for fire smoke dampers. It'll come with that spring wound shaft again. Typically, we see those in fail open operation, meaning on loss of electrical power, you want your damper to open, but you still want your damper to close if there's a fire. So that's typically where we'll see fusible link operation in fire smoke dampers. The RRL/OCI is same closure device as the RRL, so a little thermostat again, only now we have an additional on blade indicator, so an attachment to our damper blade that is connected to a little arm in that cup now, and when that arm rotates, it'll make a couple of dry contact switches at the beginning and the end of the rotation there, telling us when our damper is open or closed. So that's the OCI, open closed indicator. TOR is a closure device on the bottom left there. That's essentially a temperature override device. So probably see these most often in a smoke control application. So it's got a low limit thermostat, might sense an increase in heat, close the damper, but now you have the ability to override the low limit thermostat, bring the high limit thermostat into play, reopen the damper until that temperature is reached. Then you're probably more worried about containment than active smoke exhaust, and then you just want to close the damper and prevent the spread of flames. So that's the TOR device, temperature override. And if you do happen to come across pneumatic actuators, the pneumatic relief valve is the activation device there. It's essentially a fusible link. Position indication, certainly common to want to know if your damper is open or closed and monitor that position. So the two options really are the OCI, the on blade indicator there, open closed indicator, or the actuator auxiliary switches, which will tell you when your actuator reaches the beginning or the end of its cycle. Here's your modulating fire smoke actuator. So yeah, again, it just, if you're really trying to combine a bunch of things into one, right, and then avoid the need for additional controller balancing dampers within a system, maybe there's a way you can integrate that just using the modulating fire smoke actuator there. Few options for test stations. So locally mounted, the momentary test switch, just really a cover on the outside of the junction box of the RRL or the closure device. It's got a little red button on it. Walk up or climb up, I suppose, and push the red button that cuts the power to the actuator. You can listen or watch or check that your damper is closing. When you release the button, it restores the power to the actuator, allows the damper to reopen again. There is also a little button, a black button to the right of the red button in that picture. That's the reset button for the thermostat. So if you happen to have just a spike in heat and that thermostat accidentally trips, or a non-fire event, let's say, and the thermostat trips for some reason, squirrel runs down your duct and kicks your thermostat in, who knows, right? But you do have the ability to reset that. So that's what that kind of black reset button is next to the test button there. Of course, if you don't have a test switch, we'll always have that reset capability on those RRL closure devices. We also have the remote test stations as well on the right there. That's the GTS Greenheck test switch, few different versions there, key switches, things like that. Those have those indicator lights telling us when the damper is open or closed, so tied into one of those OCI closure devices. All right.
Hey, Alex, got a couple more questions.
Yeah, awesome. I love it.
Is there a specific closure device required for healthcare and hospitals?
Not that I'm aware of. But I don't quote me on that. I'm definitely not an expert in the healthcare construction industry, but I haven't
might be
heard of one.
Dependent on the jurisdiction, right?
Sure could, yeah, definitely.
And I know we have a lot of brain power in terms of who's attending this presentation. So if anybody wants to chime in with any insights and share some knowledge, feel free to do so in the chat. The next question we have are what options do we have for combination fire smoke dampers for vertical penetrations of horizontal wood construction corridors and non-corridors?
Yeah, so the corridor, we do have the corridor fire smoke damper option. I don't think I actually have a slide in this presentation. You're don't get asked that very often, but we certainly do have the product for that application. So yeah, to your point, horizontal fire smoke damper certainly usually seen either concrete penetration or the I-503 construction. Let me just jump down there quick. Sorry. I'll never get through all this anyway. So where we go. Here, I'm going to jump out of here for a sec. Yeah, here, this is a kind of a good one. So you're talking horizontal installations though. So typically here, fire smoke, you're either in concrete or you're in that tunnel corridor type of construction. So that's not too bad to navigate. You just need to know how you want it installed. We've got a few different installation configuration options for that. So that's our CFSD product for the tunnel corridor type construction. But anything else that's fire rated that's going to be horizontal is going to either have to be in concrete or this UL design I-503. And that's something we came out with. Actually, happy to say I was in the test lab when we were pioneering that one, but 2019, I believe, was when we came out with that. Allows a way for a fire or fire smoke damper to be mounted in the horizontal position in something other than concrete. Basically, there was really nothing until this construction came along. So outside of that, there aren't a lot of options for horizontal mounting of fire or fire smoke dampers. So those are pretty much your options there.
Excellent. And that was the model CFSD.
CFSD, yeah, that's your corridor fire smoke damper. And then I'm sorry, I don't have a slide on it here in the presentation, but it comes in, I think it's CFSD, I think it's a 211, and then it'll be like a -1, -2, or -3, and that's just how the flange and the sleeve is configured. So that's something you'll want to look at. But I think it's pretty obvious when you see the drawing.
I'll put a couple of
go.
links to the cut sheets here in the chat.
Perfect. That's good. It gave me time to talk about some of this stuff that I wasn't going to have time to talk about. Yeah, I don't want to go too deep into installation stuff, but this is something worth talking about. This is something we kind of or Belimo at least, just brought to the market. And this is the FSKN. It's an addressable damper controller, backnet compatible, and you can basically just hook this right up to building automation system, use it to perform your periodic testing requirements. Avoid some of the contractor costs possibly of hooking up all these kind of addressable systems and things like that. So pretty new to the industry, so it's still kind of taking off, but I think this one is gonna really start becoming a commonly seen feature on these fire smoke dampers here. So again, just trying to get more options to be available from the factory and make it easier to get everything in one package. So we also have these automatic balancing dampers too that we can provide with fire dampers. So kind of set it and forget it in terms of the airflow set point. It's got a little leaf spring and blade on the back that'll kind of fluctuate with the change in pressure and maintain a constant CFM through that opening. All right, now I'm really going to start flying through here. Installation stuff. Important that the fire or fire smoke damper is in a sleeve, the correct sleeve. I'm not going to say much more than that or go deeper than that, but just be aware that that damper itself does need to be in a sleeve to facilitate the installation. That sleeve has some requirements in terms of how far out of the wall it needs to come. So 6 inches max, unless we have an access door or actuator, then we can do 16 inches, but then we do have to terminate that sleeve. And if we're continuing ductwork, we'll need to make a breakaway connection there. I'll skip over this part here. Mounting orientation we talked about already. One thing I did not mention with the multi-blade products, one thing we can't do is take them where the blades are running vertically and rotate at 90 degrees. So now the blades are running, sorry, did I say vertically? I meant horizontally. Rotate it at 90 degrees so the blades are running vertically. We need special vertical blade products for that. We do have them, we do make them, but there's a little bit of a design difference. We'll put extra washers in them to help them pass the fire test and keep the blades in position. So vertical blades, usually only ever see that if someone wants actuator access at the top or bottom for some reason. But yeah, just know those are a specialized product. The dampers themselves, we've got to order them to fill the opening. This is certainly important. We can't bank a bunch of small damper sections together in the field to create one large damper. It's got to leave our factory, in an approved UL approved manner and be ordered to fill the opening that it was intended for. This is installation stuff. The important thing here is that traditionally the damper needs to be within the plane of the wall, right? So the center line of the damper frame needs to fall somewhere within the thickness of the barrier. If you do need to be outside the plane of the wall, that's what those out-of-wall dampers are for. And we are using retaining angles to secure the damper in place. We do need to, again, make sure we are following the manufacturer's installation instructions. All those instructions call for retaining angles. Few different methods that we can use, but I do not have time to really talk about many of them. So I'll just leave it here. If you're interested, the IOM, actually we have a really good 3.5 minute video on our website that does a good job summarizing all of the installation requirements. But of course, all our products as well, we've got our QR codes on them. So nice and easy to pull up the IOM if you don't have it to hand. Try to make it as easy as possible to get to these documents. We do need access to these products, right? They have to be inspected every once in a while. That's an NFPA requirement. So that's something that the LEMO FSKN can help us with as well. And then if we are connecting ductwork to it, we need to use an approved breakaway connection. So I mentioned that damper sleeve can only come so far out of the wall before we have to make a connection. And that's because we have to pass one of these tests. If I can get the video to play here. So this is a UL 555 duct impact test. Essentially, the whole reason you have to use these breakaway connections and connect the ductwork to the damper, terminate the ductwork at the damper. If you have a fire on a floor above you, you start having falling debris, something like that. If something falls and impacts your ductwork that's attached to your damper, you don't want that damper to be compromised. You still want that damper to remain installed in the wall and provide fire and smoke protection if necessary. And maintain the fire resistance rating of the construction it's installed into. So we have to do this super awesome test where we take a 55-gallon drum, fill it with 400 pounds of sand, raise it 10 feet above the damper. It's so funny because you're measuring like this string with a calibrated tape measure 10 feet, and then you're just taping it to the bottom of this barrel and dropping it on the duct and just kind of watching the carnage. But ultimately, again, we're testing to make sure that the installation method is sound, so the damper doesn't come ripping out of the wall, no screws come ripping out, the installation has not been compromised, and the operation of the damper has not been compromised. So that's the purpose of the test. Again, if you do have a catastrophic event, you want these products to remain, provide the purpose of their protection. So slow motion video there, the carnage. Of course, accessories we're always able to provide factory mounted to help save time in the field. These ones are some good reference slides I like including in here just to kind of show all the different things to be aware of about the installation. Again, I don't quite have time to really go into it all. Smoke dampers, you've got a little more leeway than the fire rated products. You can actually slide them right into ductwork as long as you're within 24 inches of the smoke barrier. Still need the access, of course, and the combination product here. Let's start wrapping it up. and be respectful of everyone's time here. Talked about the horizontal installations earlier. We have an awesome video online about that UL Design I-503. I have to trust Chris maybe to share the link to that one, or let you guys explore on your own. But
I'm working on it right now, actually. I'm getting that
don't
link.
quite have time to play that one today because I do need to talk about these things as well, right? So this is the outer wall products. So ODFD, OFSD, GFSD actually has a little grill compartment with a side actuator thing. I don't know how popular those are, to be honest, but the OFSD certainly is a popular one if you do need to offset the damper from the plane of the rated construction. All right, good summary slide here on the different outer wall product types that we have. So the curtain style products, the fire smoke damper, and then that kind of oddball grill compartment one as well. Here's an example of the installation. It allows that damper to be offset. We actually have a different type of installation method, grill installation method, where you're fastening through the inside of the damper sleeve. So pretty handy actually for certain scenarios. So good to be aware of. A few get out of jail free cards that we kind of came up with. 3-sided retaining angle. If you have an obstruction in close proximity to one of your 4 sides of your this allows install with a method with angles on 3 of the 4 sides and then fasten that 4 side directly to the opening. So that's kind of a handy get out of jail free card there. Really just a plug for all of our alternate installation methods. Website is always the best resource there. Whatever product you're looking at, if it's an FSD 211 or a DFD 210 or whatever it is, look it up on the website, scroll to the bottom. There'll be this instruction manuals part on the website. It'll have the main IOM listed at the top, and then any relevant alternative IOM or any relevant supplement will be listed under there. So it's a great way to kind of explore and see what types of things we're allowed to do with the products, at least in a world where we're not allowed to do so many things. All right, here's some what not to do stuff. Again, just a reminder, these products do have to be tested every once in a while. NFPA requires every 4 years after the first successful test, I believe. It's actually every 6 years in hospitals. There we go. There's the frequency. Just making sure people haven't come along and sabotage your damper, basically, right? That's what a lot of those pictures are. And then I did just have a little time for ceiling radiation dampers. Chris asked me to include these as well. So I do want to retouch on these real quick. So again, talking about protection of a ceiling membrane of a fire resistant rated floor ceiling or roof ceiling assembly, not a through penetration ceiling membrane of a rated floor ceiling or roof ceiling assembly. And we are limiting the passage of heat transfer. There we go. Nice red arrows there. Showed that slide earlier. We're talking about UL 555C now for ceiling dampers. Also talking about UL 263. So that's kind of the test standard for the floor ceiling and roof ceiling assemblies themselves. So we do start touching on that test standard as well. But ultimately, the important thing with a ceiling damper is to try to know what the ceiling design number is associated with that construction, and that will dictate what type of damper we can use here. So if we see a ceiling design like this that does not show a ceiling damper in it, then we cannot use a ceiling damper in that design. So that's pretty cut and dry. So again, very important to know what your UL design number is. Look that design number up. It'll give you a drawing. It'll give you a listing of what's allowed in that design. You look up something like this, we just see gypsum, we just see truss. We don't see an opening, right? So no dampers allowed if you don't see it in the design. Type application 1 here. If you see a design like this, we scroll down, we look at number 9, we see damper. Oh, we got a damper listed in here. That means we can put a damper in this type of construction. If we read a little more, there's nothing too specific about that damper, right? It's basically just describing a hinged door style damper, something that's held open that's going to close when the heat increases. So if you see something like this, where there's a generic description of a damper, Any UL 555C classified product may be used in this type of a design. So this is kind of your free for all. If you're qualified to UL 555C, you can put your damper in these types of designs that just have a generic description of a damper in it. Then we get into the more complicated ones, like the wood construction, right? So wood truss, wood joist. So designs like these are tested individually. Generally, they will list specific manufacturer and model of damper. And so if you have a design like this, you are limited to exactly what is listed in that design. Yes, specific damper must be listed in that design. However, there's nothing stopping another manufacturer from conducting essentially the same test on the same construction, just using their own damper, and now having their own design number. But now it's just so confusing, right? Because someone specs, say, design L521. That's certainly a very common one. Greenheck's version is M508, but a lot of people don't know that, and they don't know that they could possibly use alternate ceiling damper manufacturers with the same construction and the same intent of the design, because of this, this UL directory and how this thing's laid out. So that is the main point I wanted to touch on with ceiling dampers, and just to be aware of the design numbers and things like that, and make sure that you're not unintentionally limiting yourself to the damper listed in that design, and see if there's other designs out there that you may be able to use to compare. So this is a good reference slide here if you're into that kind of thing, wood truss type of design, ceiling damper designs here. I'm not going to go too much deeper than that. I got some products shown there, some videos, but look at that, 136 slides. I think I hid about 40 of them, but appreciate you guys being patient with me as we went through this presentation here. And if you have any questions, feel free to send them to Chris, copy him myself, or if you do have kind of damper product questions, the inbox is always open. So appreciate your guys' time.
Thanks, Alex. I think we did have one more question here. One of the challenges we have is achieving airflow when designer doesn't know or understand the difference between net and free area, in particular with smaller FSDs, hoping there's some awareness being shared. So not necessarily a question, but it's a good matter of fact statement, right?
100%.
You're worried about free area and pressure drops and restrictions on airflow.
100%. So that's a good thing if you're talking to Chris and looking at Greenheck, because we're well aware of that, and having our dedicated test labs allows us to really hone in the pressure drop performance on these products. So you're looking at a Greenheck product, chances are you're getting the best pressure drop in the industry in terms of damper performance. So,
and we do offer some engineering trips up to the factory, and you can see Alex in person potentially. In all his glory, and there's some fantastic damper demos, and you can actually test some of the fusible link opening and closing, and it's a great way to wake people up at 8 a.m. when you hear one of those curtain fire dampers slam shut. And there's also some great pressure drop demos too, when you're just even looking at a regular volume or balancing damper. So Alex, thanks for your time. Everyone, if you have any questions, please email me or your respective Dorsey rep. And we will get this presentation, hopefully the recording posted online. I got that asked that question several times. And hopefully we'll get to see some of you next week for our presentation on energy recovery products. So thank you, everyone, and have a great day.